there are certain things that you can do if you want your code to execute a number of times. Now, what you've probably done so far is in your programming is you've been programming in what's called the top-down method, which means by default, your code gets executed in a linear order that you put your lines of code. It starts at the top and it goes all the way down. That's called top-down programming. You probably have some instances where you want your code to execute more than once. For example, if you want to compute interest for a deposit over the period of 12 months, or maybe you want to amortize your car loan over 60 months and see how much you're going to be paying for it, or perhaps looking at the interest rate for a mortgage or the interest rate for an investment. So there's some sort of variable that you want to compute over time. Like, for example, let's just say that you want to put away in the bank, you want to put away $1,000 a year for the next 50 years. What would be your payout if you expected to get a return of like 3% or something like that? In those cases, you probably want to execute your code for however many intervals that you need. For example, let's talk about an interval. An interval is, the number of times you want your code to execute. Like, for example, again, an interval might be 60 for computing what your car loan would look like over 60 months, or 50 if you want to look at what your investment would pay out over 50 years, or 12 if you want to compute what your salary would look like if you gave yourself a 1% raise every month. So let's see how that looks in reality. There's multiple ways of doing this, of guaranteeing multiple execution of your code over a period of time. And we're going to go over one of them here called a for statement. Now, a for statement, as in, 1, 2, 3, 4, but for as in FOR, what that does is it executes your code for a specific interval. And for statements are useful because we can use them when we know what the interval is. We know that we want to compute our car loan over 60 months, or our investment over 50 years, or I don't know, if we're in medicine, we could do our blood pressure over 24 hours. So we could use for to do that. Now, what I'm going to do is I'm going to show you just a simple way that we could put in that looping structure. And I'm not going to do really control structures here. Control structures are more like how do you exit loops. But for now, we're just going to actually just put a loop in here. So let me put in the following. I'll put in the code for, and we'll put in int I is equal to 0. Let me space that out a little bit better. Semicolon. And we'll put in while I is less than 12, I plus plus. And let's just put out system.out.println. And we're going to print out I. Let's talk about what we got here. Now, this is fairly easy to understand. Now, let me clean up a little bit. Now, let's take a look at our for block. Our for block starts on line 5 and goes to line 7. So I'm missing one part of my syntax here. I need to put end parentheses here. So my for block has 3 different evaluations, or 3 different, evaluations that I put in the open and the close paren. The first one, I define what my iterator is. Remember, your iterator is the number or a variable that keeps track of how many times we need to loop through. So I is just the name of my iterator. I can name it anything, but usually in Java and in other languages, when I'm using an iterator to keep track of, which iteration am I through the loop, I is used because I stands for iterator, and you look at it, you kind of know what it is. Now, the second portion here, again, between these semicolons is my conditional. So what this says is, while I is less than 12, I want to continue my for loop. So this way it'll go through up until I is equal to 12. When I is equal to 12, my for loop will just magically stop executing. My third person is, what do I want to do with my iterator after each iteration? Say that 10 times fast, huh? What this is saying is, every time I iterate through this loop of code, I want to add one to I. Plus plus is what's called a shortcut function in Java and any other languages. What this just means is plus plus is the same as saying I equals I plus 1. All as it does is the plus plus increments I. You guys know what increments is. So I starts as 0, and then because of I plus plus, after the first iteration, I equals 1, then it equals 2, then it equals 3. So there's a lot going on here, but there's 3 things in the for loop. What is my iterator? My iterator is I. What do I start at? My iterator starts at 0. While I is less than 12, execute this code. When this code is done executing, add 1 for I. So this is a good test, kind of a good exercise just to kind of run to see what this looks like. So let's do that right now. I'm going to click on execute. And then you're going to see we get 0 all the way through 11. Now this is kind of important because this looks strange. Why doesn't it say 1 through 12? It says 0 through 11. Let me let you in on a little, maybe not secret, but how things work in computer languages. When you and I in math class, or when you and I work with iterations, let's do this in English. Let's just say we want to figure out what our, how about this? What our mortgage payment is going to be, what our rent payment is going to be over the year. So, and we aggregate it, which means, let's just say our rent payment is $800 a month. So in month 1, our rent payment would be $800, right? In month 2, it'll be $1,600 because we're just adding. Again, what we're doing is we're figuring out how much rent we're paying per month for 12 months. So in month 3, our rent would be 800 times 3, which would be 2,400, right? Month 4, our rent would be 800 times 4, which would be 3,200, and so on. I think I got month 3 wrong, but you guys know what I'm saying. So back to my point here. So you and I, we count. We say month 1, month 2, month 3, month 4, all the way to month 12. We start with 1, right? In computers and languages, 1 isn't the first number. 0 is the first number. And that's going to take a little bit of getting used to in your career as a computer programmer or a software engineer. The first number is 0. So what you see here on the right, when it says hello world, is you see month 0 through 11. You're going to have to get used to that. But basically, if you take a look at it, count our iterations, count them. 0, 1, 2, 3, 4. How many times did our for loop iterate? It iterated 12 times, right? So that's correct. That's as expected. So if we have 12 months in the year, we have 12 iterations. But, and this is what's going to take a little bit of getting used to, the first iteration is iteration 0. The last iteration here is iteration 11. So they don't really correspond to 1 through 12, are they? But they kind of do, right? Think about that. Digest that for a second. In computer languages and writing software, the first number is number 0. So we have to adjust for that. So kind of start getting used to it, even though it looks funny. So this is what we're going to do. We will say, how about this? We're just going to get used to, 0. Oh, there's different ways we can. Like, for example, if you wanted to, you could say I equals 1. And that would just default it to 1 rather than 0, and you could say, well, I is less than 13. That's one way you can kind of adjust for 0 being the first number. There's other ways too. I'm probably over-explaining it at this point, so I'm just going to move on. I'm going to go ahead and execute. So then now you'll see 1 through 12. The important part is it only iterated 12 times. What the start number was and what the end number was is kind of up to you, and it will be significant. Remember this over-explanation on my part. It will come back. I promise. You're going to look at something and you're going to remember that, and you're going to think about, wait a second, it starts at 0, and you're going to have to adjust for it. But again, I'm over-explaining it just for this exercise, so it's about time I just kind of move on. All right, so anyway, our for loop iterated 12 times. So let's go back to what we were talking about. Let's go back to rent. Let's just say we want to see our employer. We work for a property management company. And our property management company, we have a property manager named Danny. And Danny has the lease for our apartment. So Danny tells us to write a software program that takes a look at what rent would be cumulative over a period of a year. I don't know why, but he does. Someone calls in and say, hey, Danny, if I pay you $905 worth of rent every month, how much rent am I giving you over the year? And then we got a program that does that. All right, not really a bad program. I guess you could use a calculator, but we're software engineers and you're learning how to write code. So how about we do this? Let's put what our beginning rent is. So we'll say our rent is, and let me ask you this, raise your hand, right? If our rent is a whole number, pardon me, slow down, Bob. Our rent is not a whole number. It is a decimal number. What data type would I use? I couldn't use an integer. Remember, integers are whole numbers, or integrals. Remember, integrals are, whole numbers, 1, 2, 3, 4. There's no decimals in them. So what would I use? Which data type? Well, I would have to use a decimal or a float. So I'm going to use a float. And I will say that my rent is, and I'll say my rent, this is my monthly rent, and I'm going to say this. I'll say monthly rent. My monthly rent is $906.34. Okay, so far so good. So anyway, how about we do this? We want to iterate, right? We want to take our monthly rent and we want to add the monthly rent for each month. So how about we do this? I will put code in my for loop because remember, line 9 will execute 12 times, right? So how do I do this? Let me put in, for example, the monthly rent. So we'll put in monthly rent. Actually, you know what? Hold on. Let's do it the following. How about we do this? We will say print line. We're going to do this step by step. If you hear me hemming and hawing here, it's because I'm trying to break this down into individual steps. So we'll say print line monthly rent. All right, so let's run this. So how many times, virtual hands, put them up in the air. Put your hands in the air if you just don't care. Put your hands in the air. Okay. How many times will line 9 execute? It'll execute 12 times. So let me execute. We're not done. I know you're like, Bob, it's just going to say the same thing all the time. And it kind of does. What did I do wrong here? Let's see. Can't find, did I spell this wrong? Let me see. Month E. Oh, you know what? Yeah, I got a syntax error here. See what I did? I got this spelled wrong. So let me go back and spell this right. And print this out. And execute. I still might have one error in here, but let me see. Oh, look, here we go. Look at this error. Incompatible types. Lossy. Remember what lossy means? Lossy means it's trying to approximate. Java is trying to approximate what we're doing and it doesn't know. So we have to say that this is a float. So we put an F there, right? Because otherwise it could be a decimal. It could be any other kind of number. But we're saying it's a floating decimal point. Remember, float means floating decimal point. It could be one position, which would be tenths. It could be two positions, which would be hundredths, three positions, thousandths. Look up float if you like. You know enough about it to get it working. You can look up the rest. All right, so let me execute my program. And you're going to see this 12 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, so line 9 did execute 9 times, but it's just showing me my rent, $906.34. Remember, we want to, aggregate or cumulative. Say that 10 times fast, Mr. Rogers. Sure you can. Cumulative. That's a funny word. Let's say that together. Cumulative. I'm not getting it right. Let's do the following. In line 10, we will say this. We will say, after we print out the rent, we want to do the monthly rent is equal to, and here's our algorithm, simple algorithm, monthly rent plus, and let's add $906.34. And I'm just going to put the F in there for float. So I'll pause a little bit and slow down, and take a look at line 10. Line 10 is really our algorithm. Our algorithm is we're just going to take whatever the rent is, and we're going to add $906.34. So every time we go through, monthly rent is going to really accumulate. Now, there's really not a word for this. Some people say accumulators. Some people say aggregators. It really isn't. It's just a formula. What the formula is up to you. Remember, you as a software engineer, as a computer programmer, it's going to be all about algorithms. That's what code does. I mean, code does things. I mean, it's great to have websites that have little floating icons that show your company icon, but real software is really just putting together programs that implement algorithms for you. Now, this is a simple program that computes rent for a property management company. Now, think about this. The bones of a complex program are already here. You have a Java program that executes, when you want it to. It's got a for loop that goes through this code 12 times. It takes a number and accumulates it and then prints that number out. That is what the most complex programs do, except this one's just a simple one. I mean, this could be an insurance program that looks at risk liability for different demographics. This could be a pharmaceutical program that looks at correlations between your odds of getting COVID as of for different metrics, such as the amount of hours you spend in a drinking establishment compared to a CTA train or to something like that. So what I'm trying to say is you're writing a simple program here with a simple algorithm, but once you get these basics down, you just make it harder. You make it more comprehensive. You make your code do a little bit more. So you're starting to see the real value of writing code here and using mathematical algorithms and equations to do things. Like, for example, you take a look at this. We got a simple program that looks at your rent and says over 12 months, I could look at it and say, well, on month 10, this is how much I have in rent. Well, what if we expanded this? I mean, you could probably look at this and say, you know what, I could do this in a calculator fairly easily. And you can. All right. Well, how about if your renter was going to be there for 10 years? That's 120 months. What if they were going to be there for 100 years? Okay, maybe they're not going to be there for 100 years, but maybe someone else will be in that apartment. And your property manager says, how much rent can I get for this space over the next 100 years? And then might give you a different algorithm and say, okay, well, the monthly rent is $906.34. And every year or every 5 years, we're going to raise the rent by 6%. Now, all of a sudden, your calculator thing, it's not working out for you now, is it? You got to be pretty quick and fast. Well, that's what software does, and that's what you do as a software engineer, is you're going to implement these algorithms not to loop through code a dozen times, maybe millions of times. Where, how about this? You're writing pharmaceutical software, or how about this? You're working and developing clinical trials for a drug. You might loop through millions of different scenarios. And you might work with physicians and doctors and clinicians and research scientists and mathematicians that give you algorithms. And you're like, well, I don't know anything about the pharmaceutical industry and I know nothing about medicine, but doctors do. And doctors and research scientists can give me the equation of how they come up with a probability of you getting, malaria based on metrics such as your gender, the place of the world that you're from, your age, your and maybe a dozen other metrics. So you would write an algorithm to do that. So this is your first real dive into that. It's a simple algorithm, but it counts. It really does. All right. So anyway, soapbox done. Sorry. Let me execute this code. And we can look at this and we could say in month 1, it's $906, right? And in month 12, it's $10,876.79. Actually, no, 7.9 cents. Again, don't worry about rounding now. You're probably looking at this and you want to clean it up. You want to make it look nicer. Don't worry. You'll do that later. Right now, let's get the numbers. It's all about numbers. It's all about algorithms, and you're starting to see that. So I'm going to start wrapping this up here. This was kind of an introduction to a couple of things here. I wanted to show you like branching statements, and I didn't show you any here because we need something to branch. So ignore all that. So to do that, I needed to show you a flow of control statement, or a looping statement. I'm getting all fouled up here. So that's what this for loop was. This for loop was basically a looping statement that goes through, X amount of times. And I chose to use, for a looping statement, I showed you a for loop because for loops are easy to understand. And we use for loops when we know how many times we want to go through the code. In this case, we want to go through 12. There are other looping statements. We'll go over those at some other time. I also wanted to show you and kind of demonstrate to you that when we write code, it's not always about hello world and Mary had a little lamb and to do cute things. It's to do real work and to do real math. Now, even in this day and age of the time that you're watching this is the basis of software engineering. This is what we do. So writing code does all this, and you got your first introduction to doing that now. So you should know at this point at least how a for loop works. You should know at least the concept of iteration and how you could get code to execute multiple numbers of times. You know that there's more complex ones out there. There's other things that you can do other than a for loop that do kind of the same thing. We talked about algorithms and how to implement algorithms and the importance of understanding that's really what you're doing here in writing code. So that's all I have for you guys today. So thank you so much for listening. And if you've made it this far, thank you for watching my demonstration. If you have any questions, please reach out to me. And I bid you all a very well rest of the day. Thank you.